Hello there. Hello and welcome. Great that you could all be joining us today for our live webcast. This session's entitled Connecting the Unconnectable. And what we're going to do here is really just take a bit of a detailed look at some of the issues that have come up around some recent best practice guidance from the UK NCSC. And these are around how you go about implementing cross-domain security. Now, I should say here, the reason we called this session Connecting the Unconnectable is really because, I suppose for many years, connecting an isolated network to a wider corporate network or even to something thoroughly untrustworthy, such as the internet, well, that was just really deemed too great a security risk to consider. And so in that sense, it was deemed unconnectable. Now, as you know, things have changed. And there are now ways that you can connect the unconnectable, as long as you've got the right expertise, the right guidance, and the right technologies to help you. And that's something that we're going to discuss in today's session. Now, today I'm joined by Deep Secure's Senior Solution Architect, Tim Freeman. Tim not only runs the solutions team here at Deep Secure, but more crucially from our perspective today, Tim's helped some of, well, the most security conscious organizations in the world really. He's helped them to design and implement cross-domain security solutions over probably the last 20 years. So with that in mind, he's exactly the type of chap we need with us today. Someone who can look at the issues, look at some of the things you need to consider in terms of cross-domain security, and the risks, and how to mitigate them. Okay, so before we start, a key thing here, guys, we'd really like you to get involved with this session. Okay, so please use the question facility on the GoToWebinar dashboard of your browser or of your session. Use that question facility and submit your questions for Tim as we go along or at the end of the session. It's really up to you. One of our colleagues, Josh Short, is joining us today, and he's going to be keeping an eye on the questions that are coming in and making sure that we deal with them, making sure we record them, and that we get back to you either during the course of this session or afterwards with what you've had to say and what you think about what's been going on. Okay then, well, hey, good morning, Tim, how you doing?
Good morning, John. Yeah, very well, thank you. Looking forward to this.
Fantastic. I mean, I guess, let's start with the real basics. Could you just, give us a definition, please? What's meant by an isolated network?
Okay, yeah, I mean, for me, I think an isolated network is, as its name suggests, something that's kept apart from other networks. So either that's within an organization, keeping two networks separately, or keeping a network separate from the internet. And the reasons you might have to have isolated networks, that might be because you've got maybe some critical functions that are running in there. So think industrial control systems, or it could be that the network has some really sensitive information, things like customer data or intellectual property that you want to keep safe. And a connection to this sort of network, that obviously could be a way in for an attacker to either steal your sensitive data or to get at those critical services. So the safest thing to do is to isolate it from everything else. But I guess really that there's always a need to get information in and out of these sort of networks. So you have to find ways of doing that safely.
Yeah, I guess, people think they've got an isolated network when many times it's less isolated than one might think, and indeed less isolated there than they might hope. So, yeah. So the notion of cross-domain and a cross-domain security solution, what's that actually mean in this context?
Yeah, I mean, a cross-domain solution, it's something that allows your business processes to run, but making sure that the worst doesn't happen to either your sensitive data or those critical functions. So like a good cross-domain solution is going to enable the information flow, and it will strictly control it to make sure only the authorized users and systems can access it. And it's there really for two main functions. So the first is to stop any malware getting into your system. And the second is to make sure that any information that should be kept inside doesn't escape. And normally we talk about two types of cross-domain solution. One which is allowing users to access information in that network from the outside, or one which allows users to move information between the outside and that system. But fundamentally, they're the same thing. They just use different protocols and different data formats.
Okay. Well, many people might think that it's the purpose of most cybersecurity solutions, technologies, products, call it what you will, to do this sort of thing. So, exactly how does a cross-domain solution differ from, a commodity or a mass market cybersecurity product?
I think it differs in a few different ways, really. The first is when you're building a cross-domain solution, you really need to take care of and think about the real end-to-end system. That includes what the endpoints are doing and how they interact with any cross-domain solution, and that's not usually the case when you're sort of looking at commodity cybersecurity boundary products. A cross-domain solution is there to protect the network from attack while allowing the information to flow, and so to do that, it needs to understand the information that's flowing in great detail, and also a cross-domain solution has to protect itself from attack. So that means making sure that attackers can't use your cross-domain solution itself to become a launch pad to break into a system. It is after all, it's a route into the network that it's protecting. So it needs to be able to do that as well. And commercial gateway software is often built using quite complex software because it has to be able to understand those information flows and make policy decisions based on them. And that the result of that complexity leaves them vulnerable to attack. So if you just look for antivirus scanner vulnerabilities and sort of search for that, you'll see a big list of vulnerabilities found in AV products, for example. And then I guess lastly, the cross-domain solution's got to be accreditable. So when you're building a cross-domain solution, there'll be a security accreditor responsible for making sure that the system does what it says it does, that it meets the security needs. So it has to be, a cross-domain solution's got to be verifiably secure. It needs to be able to demonstrate in a really simple way that it protects both the network and itself.
Okay, so we can say performing security functions, able to defend itself, and pass the scrutiny test. It can be examined, evaluated, scrutinized, and it's going to pass those tests. Yeah.
Yeah.
Okay.
Yeah, exactly.
Fantastic. Well, look, let's dive into a bit of detail now, because what really got us going on this topic was a main driver, if you like, for today's session. Was a publication of some recommendations from the UK's National Cyber Security Centre, the NCSC, in January, and these covered cross-domain security. And in fact, if you've got a sort of summary screenshot of it here at the moment on the screen, you can see it's rather entertainingly headlined 13 things that need to be good to make a secure cross-domain solution. And by the way, for those of you guys who are intent on following this through, you'll see the URL at the bottom right of the screen there, where you can sort of read up on this in detail. And obviously, this is really first-rate advice from an organization that is frankly leading the world right now in promoting good practice for cybersecurity for citizens, organizations, and I guess ultimately society at large. So it's a great place to start. And what we're going to do in today's session specifically is focus on the first 3 of these 13 good things. There you are, you can see them highlighted on the screen at the moment. So we're going to look at network protocol attack protection, at content-based attack protection, and at protecting against the unauthorized export of information. So I guess, Tim, we'll work our way through them. Let's ask the obvious question. Security principle 1. So we're talking about network protocol attack protection. Can I ask you, just give us an idea what that means and what you think of, perhaps in terms of some examples of what sorts of attacks you've got to protect against there.
Yeah, sure. So, attacks on systems can come in many different forms, and that includes attacks using the protocols that are used to transfer the information. So if you think of the way information is transferred between networks, you can look at a stack of protocols that you have for the internet. So there are different layers from physical to network to transport to application layer, using well-known protocols, so things that people will have heard of like TCP and IP and HTTP and SMTP. And that all of those things, they present a means for an attacker to deliver some dangerous data by trying to break the protocol handling software of a device. And the more complex that protocol is, the more complex your software has to be to handle it. And so you're more likely to have bugs and vulnerabilities in your protocol handling software. So if the attacker can exploit any of these, either known ones or new, currently unknown ones, then they can start to get a foothold into the system. Recent examples of this include things like vulnerabilities found in the TCP/IP stack used in some Cisco and other products. Those sort of things, they can, they're fairly widespread.
Okay. Now, I mean, I know that there are, documented examples of people compromising an organization using network level attacks. So, based on your experience and the best practice and guidance that the NCSC's published, what's the best way to mitigate against attacks at that level, at that network level?
Yeah, I think something that would be called a protocol break is the best way to defend against these attacks. So rather than let the attacker connect directly to your protected network, you can put a proxy in the way. And so any direct connections come into the proxy and they're terminated there. So the connections aren't made direct to your protected network. And so you can sort of terminate those protocols in your proxy and just get the content out and extract the content and pass that on to the protected network. So any new connections then that you make into the protected network to carry the content, that they're sort of made by the cross-domain solution. They're not made by the attacker, and so they're under your control. And if you can have a simple interface between your inbound proxy that's handling those connections from the outside world and the onward connections that pass the content onto the protected network, if your complex software then that's in the proxy that's handling those inbound connections, if that fails, the attack can be stopped at that point, and so it doesn't propagate on to the destination. So that's a really key way of preventing these sorts of attacks. Other things that can help, one-way flows can help protect against the attacks too. So if you're importing information, then making sure the information just flows in that direction, and that prevents attackers getting any feedback on the success of any attack attempt they're making. And similarly, if you're exporting information out of a network, making sure the flow is enforced in that way, that prevents any import of malware whilst you're exporting data. And these sort of one-way flows can be enforced using optical or electronic diode type technology.
Okay, fine. So at least, in terms of principle one, at the network level, we can really say protocol breaks, we can say proxying, and enforcement of one-way hardware, one-way flows either in software or in hardware. Yeah,
exactly that. Yeah,
fantastic, good stuff. Excellent. Okay, well, I guess that leads us naturally into security principle number 2, and this was the second area the NCSC focused in on in terms of a good thing to do from a cross-domain security point of view, and this was covering content-based attack protection. So again, I mean, logically follow on, can you tell us a little bit about the risks there? Maybe give us a couple of examples.
Yeah. I mean, for network level attacks, we looked at the protocol stack and we stopped the story at the content and made sure we extracted that from those application protocols and all the lower layer protocols so that we could safely carry it to the destination. And that content could be, a Microsoft Office document, it could be a PDF, an image, or, a container format, so something like MIME or a zip file carrying multiple items. But actually, if you look at that content, it also contains layers. So it's made up of the information that the users need to see and the carrying data. That's the file format. So things like Word or Excel, or the container format like MIME or a zip file. And those formats that carry the information, they're typically pretty complex as well. and they have to be to enable the rich applications that the end users want to be able to view and edit, edit the information. So cross-domain solutions that are making decisions based on what's in the content, they have to be able to handle those complex file formats. And obviously to do that, they have to use complex software to handle the complex file formats. And like we said before, anytime you bring in complex software, it can go wrong, and it likely will go wrong. And so it can be exploited, whether that's at the endpoints in the destination network or in your security boundary devices that are analyzing that complex content to see if it's safe. And there's loads of examples of this. So nearly all of the attacks that you read about today, they're launched from some sort of complex content like PDF files, Office documents. Some of them use the functionality offered by those formats to run active content, so things like macros, and others just exploit software errors in the applications that handle those structures, and they enable an attacker then to run their own code.
Okay, Tim, but you know what? I have to take you to task here just for a moment. So, this is a multi-billion-dollar industry. It's cybersecurity industry. It's a huge range of defensive technologies available. There's a whatever it be, antivirus or sandboxing or artificial intelligence or machine learning, and nearly all this stuff is there, ostensibly at least, to combat content-based attacks. What do you think special about the approach recommended by the NCSC for cross-domain?
I think it's the same as what we said about the network-based attacks. The same thing applies here, really. That the defenses have to be able to defend themselves as well as the system they're put in to protect. And because they're handling complex content, that they put themselves at risk from attack by that content. So in cross-domain solution, you have to take some special actions to make sure your boundary device doesn't propagate any attack. When it's handling that complex content.
Okay, you can see that. You can see that here. Can you just talk us through that?
Yeah, so you can treat content layer attacks in the same way that we treat the network layer attacks. In this case, if you treat the content as information in the file format, then you can extract the information from that complex data structures, and you've only really then got to pass the information on to something that can recreate those data structures to pass the information to the destination. So in the same way that we at a higher level for the network attacks, we just extracted the content and passed that across, and then sent it on to the destination under control conditions. You can do the same with the information inside the content, and you pass the information again. If you can pass the information in simple data structures using simple protocols, then any time you've got an attack using that complex content, and you've got any data handling software that goes wrong in your proxy, it won't propagate onto the destination, so it will get stopped in your proxy. So a bit like you had a network protocol break, you could call this a content protocol break, and that's really quite different to the traditional way of stopping malware getting into a system. There's no recommendation here to try and detect the malware using the well-known techniques of commercial products, so things like looking for virus signatures or checking the behavior of content when it's opened in a sandbox. And there's no talk of machine learning to try and second guess the attacker's methods. They're all techniques used today in commercial products, but they really fail to fully deal with the malware problem.
Interesting. I like the words fail to fully deal. So, traditionally at least, we'd be talking about environments where there has to be an expectation that the system cannot fail, that it mustn't allow anything bad in, and I guess that's what's acting as the bedrock for this advice and guidance, really. So I'm taking away from this the same kind of principles as for the network layer in terms of enforcing protocol breaks, using proxying, and using simple data structures as being ways to ensure the content cannot carry an attack, basically. Is that correct?
That's absolutely right, John. Yeah.
Fantastic. Definitely. Good. Okay, well, look, we've got another principle to just take a little bit more of a detailed look at, and that was security principle 3. And this is a slightly interesting one because we're talking about information traveling in the other way. So we're talking about protection against unauthorized export. So can you just step us through some of the risks there, Tim? Would you mind?
Yeah. So I mean, so far we've talked about stopping malware getting into a system, the first of the two key controls of a cross-domain solution, and stopping that malware coming in and doing any damage. But another real risk for any system is that your sensitive data will get out of the network, and that could happen as a result of malware getting in, which we're trying to stop with those first two controls. But it could also happen easily, by mistake. So someone sending some stuff out and they didn't realize the document, for example, had something sensitive inside it. Or it could be somebody on the inside deliberately trying to get data out of the system. Maybe they're trying to sell some information or trying to cause some harm. So, think a disgruntled employee.
Now again here, if we step back from the world of cross-domain and look at the broader cybersecurity landscape, there's a pretty established market for data loss prevention, DLP products and technologies. So what specifically has the NCSC had to say about the recommendations for this in terms of cross-domain?
So I mean, cross-domain solutions, it's got to be able to stop data leakage while enabling the business processes to flow. So part of that is around authenticating the users of the cross-domain solution, because we want to make sure that only the authorized users can send data out. And it also has to look at what's leaving the network and trying to see if it contains anything that breaks your export policy. That's what commercial DLP solutions typically do. But another part of the solution might be to include some sort of manual review into the process. So having one or more humans in the loop inspecting the data before releasing it. And there's sorts of different tools and techniques you can use here to help in the export. So things like adding security markings on the data, maybe digitally binding those markings to the data so that the cross-domain solution can tell A, if the data was intended for release, and B, it's been authorized for release along the way. And I guess the last thing is what commercial solutions don't do too well is stop hidden data. So data hidden in unseen areas of complex file formats. Things like steganography, where you can use techniques like that to exfiltrate data, and that sort of technique will get past your traditional DLP solutions. In fact, the techniques that we talked about for stopping malware by extracting the information from complex data structures, you can use those same techniques here as well by sort of leaving behind any additional data that's hiding in those file formats when you're exporting it as well.
Now that's interesting. So in effect, your inbound content level protection techniques also help to mitigate the risk of someone trying to smuggle something out in a concealed form, going the other way. Yeah.
Yeah, can do. Yeah.
Fantastic. Okay, that's great. So we've taken a look at the sorts of things that principles 1, 2, and 3 cover, and they form, I think, the absolute heart of the security controls that you would consider putting in to make, to quote the NCSC's phrase, good things for a cross-domain security solution. So let me ask you this. The organization in publishing this stuff has provided a lot of, at times, extremely detailed technical recommendations, which is fantastic. But let me ask you this question. In your view, how widely applicable is this to UK PLC in general?
I think, according to the NCSC, these sorts of solutions, they're applicable to anyone, but really relevant for systems where integrity or confidentiality are paramount. So that could be any systems handling sensitive or personal data, classified information, anything doing valuable transactions, or systems that are operating industrial control systems, for example. I think that the key point here for me is that cross-domain solutions in the past, they've been built as bespoke systems, large, expensive, not really reusable elsewhere. And that's put them out of the reach of most organizations. And we've not really talked about Deep Secure, but what we have done at Deep Secure is built COTS products which implement those same defensive techniques that are recommended in these principles, and they can therefore be used to build secure but really affordable cross-domain solutions for anyone. Anyone who takes security seriously can use these same components or these same principles.
And that's interesting too, isn't it? Because you could read this best practice advice, this guidance, and be forgiven for thinking that it's all very good in theory, but you know, how on earth do you make it happen in practice? I guess that's essentially where Deep Secure is able to offer a way of making it a reality in a way that makes sense from security and cost and implementation perspectives all round.
Yeah, no, definitely.
Great stuff. Great. So Tim, thank you very much indeed for that. It's been a really interesting look at those three principles. I know we've got some questions, so I'm going to ask our colleague Josh, who's also in attendance today, to just take us through them and see what some of you guys out there think of all this and what your thoughts are. So Josh, I don't know if you're there to come in at this point. Could you take us through some of the questions and feedback?
Yeah, not a problem. Thank you very much, John, and thank you very much, Tim. That was really insightful. So yeah, we do have some questions from those in attendance today. So the first question is from Parminder, and Parminder asks, by putting in these extra devices, isn't the attack surface going to be increased and therefore increasing risk?
No, I think you're trying to decrease the attack surface by and it's all about the sort of simplicity of the interfaces is the way you can decrease the attack surface by. So you can't get away from the fact that an attacker is going to have access to an interface. So what you have to do then is to expect that interface to be attacked and to be potentially compromised, and it's the next stage on then. So by putting proxies in, you can effectively stop the attack hitting your protected network, and it hits your outer boundary, and that's where it gets the attack gets stopped.
Okay, thank you very much for that, Tim. I hope that answers the question, Parminder. I have the next question from John. John asks, what are good practices to consider when looking at network protocol attacks? Is it multi-layered with different vendors, or stay single vendor?
I think either approach is fine. I think you know, there's an argument for defense in depth, definitely. I think the key thing here is, again, it's the principles of how you're dealing with those attacks that's the important thing. So it's about proxying the data and not necessarily relying on detection-based techniques. There is a place for detection techniques as well, but I think the key principle here is looking for ways of dealing with those sorts of attacks in the way that the NCSC are proposing in those principles. So it's more about how they're defending against them rather than the number of different defenses that you have.
Okay, thank you very much again, Tim. So a further question from Steve. Steve asks, from the export side of the principles, would this be considered as a data diode in the old world, or a next generation, more advanced data diode now?
Yeah, I mean, I think that there are issues with sort of data diodes as just a device, because whilst you really want to make sure the information only flows in a certain direction, most protocols and most ways of sharing information require a two-way conversation to do that, and so a diode obviously stops that and makes it harder to have your proper two-way conversation to send information one way. So it doesn't, you know, a data diode in perhaps the old sense of the word isn't necessarily the right solution, and you know, something that can control the flow of information is more important. And so that might be effectively two one-way flows that allow a limited amount of feedback back to be able to know that the information has got to where it's going to go to, and also to be able to give you the sorts of flow control when you're sending, you know, data at speed, that you want to make sure you control the flow of information as well. So it doesn't have to be a physical data diode and nothing more. It's more about controlling the flow and having control over that flow.
Excellent, thank you very much. Kind of following on from that question, are these solutions CPA accredited, for defence and government sector users?
So that will be nice eventually when there are schemes to be able to evaluate the products. So at the moment, the situation we're in the UK certainly is that the schemes, there are no real finalised schemes to evaluate cross-domain products. So things are starting to move in that direction, and when they do, then products will get evaluated under those schemes. But the way things happen at the moment is that the products get put into solutions, and the solutions get accredited for use in that particular solution, and then you sort of pretty much have to do that each time for each different solution that they get it put into. So there is a bit of an overhead there. I mean, you can reuse some of the security arguments, I guess, between solutions, but I think what we're really waiting for are schemes that allow us to evaluate the products to be able to get that sort of level of assurance.
Okay, and final question is from Mal. So Mal's asked, what do you mean by a complex data format?
So if you think a file format has to represent your business information in a file structure, and to do that, it's got to really support all of the different elements of the information that could be there and could be present. So, even for simple file formats, so think of a Windows bitmap, for example, there's your actual pixel data for the image itself, but there's also other information like on the size of the image and the color palette that might be used and that sort of thing. All of that has to be represented inside the file format. And if you take more complex applications, so things like Microsoft Office, you can store many more types of information along with the words that make up the document. So there's things like metadata, there's information on fonts, track changes, just all sorts of things that you have to be able to represent. And that all has to be represented in a way that the applications can easily access the information that they need to present it. And so it has to cope with that. And sometimes that might be sort of links from one part of a file format to another. It could be read in different ways from top to bottom or bottom to top. So some file formats have headers that identify the content, others don't. So there's a lot of complexity there just to be able to represent the information. And also you have things like padding in areas of the file that aren't used, but they have to be padded out. And so it doesn't necessarily affect the look and feel of the file when it's opened, but there is space in that file for more information. And all of these different things, all of that complexity, that's where the attackers have an opportunity to try and exploit it.
Thank you very much, Tim. So unfortunately, that's all the time we've got for questions. There are a couple more that have come through, and we'll respond to those directly. And also we'll be distributing a summary of all the questions that have come through across both today's session and also the second session we have as well. So thank you very much for those of you who have sent in questions, and thank you very much, Tim, and I'll hand over to John to close.
All right, guys, that was great. Really enjoyed that. Fantastic to hear so much authoritative standpoints, much authoritative views on the subject. If you want to learn more, please get in touch with us. Use the links on the screen right now. And that aside, really only remains for myself, for Tim, and for Josh to say thank you very much. It's been a great session. I hope you enjoyed it. Enjoy the rest of your day also, and we look forward to speaking with you soon. Cheerio now. Bye-bye.
Bye.